Okay, I'm going to work out a few problems from the 17.1a assignment. I want you to remember that, even though we're not in class, you need to write down the ones that I did for you. You need to always circle as correct or X as wrong the odd problems, because the odd problems always have the answers only posted. But for the ones I work out for you, you need to fix them and make them right. That's what shows me you're putting in some effort. Just like if I was sitting in class and working problems for you, you'd have to fix them and make them right. Okay, I hope you already watched the 17.1a notes. If you didn't, stop this video, go back and watch the notes. You have some basic idea of what's going on. In this section, they're asking us to first find the missing side. That's what I'm going to do first. When you have a right triangle and you know two sides, the easiest way to find the missing side is Pythagorean theorem. We're going to go a squared plus b squared equals c squared. It doesn't really matter which ones we call a and b, but the c is always your hypotenuse. So this will be 16 squared. And the others, if I call this angle A, that's going to be my A side. So 11 squared, B squared. Use your calculator if you need to. Some of these I already know. Some of these I just have them on a piece of paper, so I'm cheating a little bit and just writing down numbers. 11 squared is 121 plus B squared equals 256. We need the b squared by itself, so we'll subtract 121, which gives us b squared equals 135. In this section, they don't want any decimals, they want exact radical answers. So I'm going to come over to the sign. I'm going to say 135 ends in a 5, so I know 5 goes into it. 5 goes into there 27 times, and 3 goes into 27 9 times, and 9 becomes 3 and 3. Remember that we're looking for matching pairs. So a pair of 3's will become a 3 outside, and these other two, even though there's another 3, doesn't have a pair. They got nothing. They stay inside 5 times 3. So that when I come back over here to my answer space and I do square root, I get b equals 3 square root 15. That's lovely, but they're also asking us to find tangent theta. And I know that tangent deals with opposite over adjacent. If I go back to my triangle, the theta angle is right here, and the one opposite from theta is the one I just worked out, 3 square root 15. And the side adjacent, which means touching the theta, is 11. So we have 3 root 15 over 11 is equal to tangent theta. 3 and 11 can't reduce with each other. I have no radicals on the bottom. That's my final answer. We're not going to do any inverses. Nobody asked us to find the measurement of that angle theta. That's all we need. For those who are wondering, this symbol is pronounced theta, and it's just a Greek letter. They usually use theta for angle measurements. Theta is not that. It's not a cursive O, but some people do write it as long as it's cutting like halfway down so it doesn't look like an O. Okay, let's look at the next one. In these triangles, ABC, angle C is a right angle. And we're going to assume that a right triangle works that way unless they tell us otherwise. We're going to find the missing side, the exact value of the trig function indicated. No decimal answers. Simplified radical form if necessary. This triangle picture was not drawn on your assignment, but this is what we will always be using. Capital C, straight across from that, hypotenuse is lowercase c. Capital A, straight across from that, opposite from that, lowercase a. Capital B, opposite from capital B, lowercase b. Again, always working out that way. That's one of the things that we talked about in the 17.1a notes. So, if we're looking at this one, we're saying A is 10, C is 14, find the B. Even without putting anything on the picture, I know I'm going to do A squared plus B squared equals C squared. So that is 10 squared plus B squared equals 14 squared. If you ever see that the biggest number is not the one you set up for C, go back and rethink things. This is 100 plus B squared equals 196. Subtract 100 because we're trying to get the B squared by itself. And I get B squared equals 96. And square root on both sides, square root on both sides. It's asking for exact, so I'm going to come over here and work on splitting up my 96 with a factor tree. I know that 96 is 4 times 24, and that becomes 2 and 2. 24, let's call it 3 times 8, and 2 times 4, and 2 times 2. Pair of 2's, single 2. Pair of 2's, single 2. Left over 3, left over 2. 3 times 2 goes inside, so that this becomes B equals 4 square root 6. Not done with the problem, but we can write that in this space. I also need to know the tangent of B. Tangent, if you think SOHCAHTOA, which is at the top right corner of the paper here, tangent is opposite over adjacent. So I'm going to say tangent B equals the side opposite from B, which is always my lowercase b, over the side adjacent to B, which means the side touching B. But even without the picture, I would know it's not lowercase b, because we already used that for opposite. It's not C, because that's the hypotenuse. It's the A value. So this is going to be our B value, 4 square root 6, over our A value, which is 10. And 4 over 10 can reduce, so I'll call that 2 root 6 over 5. Basically, I said 2 goes in there twice, 2 goes in there 5 times. 6 is also an even number, but 6 is inside the radical, 10 is outside the radical. They couldn't reduce each other anyway. So I'm going to come up here and write 2 square root 6, 2 square root 6 over 5. Okay, for number 6, they also gave us 2 sides out of 3. We're going to start with Pythagorean theorem. A squared plus B squared equals C squared. Find the missing side. Then we'll go back and think about sine A. So they didn't tell me my A this time. The B is 1. The C is 3. A squared plus 1 equals 9. Subtract 1 on both sides. A squared equals 8. So I'm going to have to find the square root of 8. Right here, let's think about 8. 8 splits up. 2 times 4, 2 times 2. I can take a pair of 2's and make a single 2. Left over 2, he's staying inside. There's my A. 2 root 2. If you didn't print this worksheet, please make sure you are circling your answers. And when a problem has 2 answers to it, make sure you're circling both of those answers. Okay. Now that I have the missing sign, I'm trying to find the sine of angle A. Sine of A. And remember that sine is always opposite side over the hypotenuse. And if we look back at this picture, we remember that anything that's opposite from an angle A should always be a lowercase a, and our hypotenuse will be a c. We now know lowercase a, 2 root 2. They told us the c in the first place was 3. This one has nothing we can reduce. I'm putting it straight up here in the answer space, 2 root 2 over 3. Or if you didn't print it out, make sure you're circling that. We're not doing inverse sine, we're not finding the angle, we're just asking for the sine. Okay, I think I'm going to put the next couple problems on another video. Make sure you look for the other video too.